chapter 7. So we start off with acid and base. So we need to know what is an acid. So there are 3 definitions of acid. So all of these definitions still relevant and complementing each other. So we still use all of these definitions. So the first one is Arrhenius. So Arrhenius state that acid is a substance that dissociates in aqueous solution to produce hydrogen ion or hydronium ion in aqueous solution. So HCl is an acid. So when it dissociates, it will produce H+. Okay, so HCl is an acid. When it dissociates, it produces H+. So H+ can combine with water to become hydronium ion. So basically H+ and hydronium ion actually the same thing. Okay, the difference is hydrogen ion form when H+ combine with water. Okay, so the next definition come from Lewis theory. So Lewis theory state that acid is a substance that can accept a pair of electrons to form a covalent bond. So acid, in other words, is a substance that can accept 2 electrons. Okay, so electron pair acceptor. So the substance that can accept 2 electrons are positive ion or molecule with incomplete octet. So boron, beryllium, another boron. They can accept 2 electrons. Okay, the last definition of acid come from Bronsted-Lowry. So this is the crucial one. Acid is a substance that can donate proton to another substance. So acid is a substance that actually can donate a proton to another substance. So HCl can donate proton to water. So HCl is an acid. So the product from HCl, so the remaining thing from HCl after the substance donate H+ is Cl-. So Cl- we call it as conjugate base. So acid will be paired with conjugate base. Okay. So next definition of base. Okay, similar like acid, we can define base into 3 different definition, and all of this definition is relevant. So we look at Arrhenius first. Acid is a substance that can dissociate in an aqueous solution to produce hydroxide ion. Okay, so we have sodium hydroxide. So when it dissociates, it can produce hydroxide ion. So another definition of base is a substance that can donate a pair of electrons. So base is a substance that can donate 2 electrons. Okay, so the example are negative ion or molecule with lone pair. So ammonia here has lone pair. So ammonia can donate a pair of electron, 2 electron. So water molecule, O in water molecule has lone pair. So O in water molecule can donate 2 electrons. Okay, the crucial one, definition of base come from Bronsted-Lowry. Base is a substance that can accept proton from another substance. So water can be acid, water can actually become base. Water is amphoteric. So if you want to know whether water is an acid or base in this equation, so we need to look at another substance. So HCl is an acid. So HCl will donate H+. So in this case, water is acting like a base because it accepts the H+, okay, becoming H3O+. So water in this case is a base, and then the product when it accepts H+, we call it as conjugate acid. So base and conjugate acid is a pair. In the following reaction, identify acid-base conjugate pairs. So when we talk about acid-base conjugate pairs, we need to remember definition of acid and base from Bronsted-Lowry. Bronsted-Lowry is the one that introduced these theories, pairing of acid and conjugate, base and conjugate. Okay, so right here we have ClO. So this is the end product. So we can clearly see that ClO minus accept. So this one is a base because it's accept H plus. So this one is conjugate acid. Okay, so we have water. So water is the one that donate the H plus. So water in this case is an acid. So the product will be conjugate base. So in the equation, we have acid and base. At the same time, the product from base will be conjugate acid. The product of acid will be conjugate base. Okay, next example. So here we have CH3NH2. So the product is CH3NH3 plus. So from 2 hydrogen, increase number of hydrogen. It means that this molecule accept proton. So this is the base. So the pair is conjugate acid. So this ion donate H plus. So from 2H, it become only 1H. So this ion donate H plus. So this is an acid. So the pair is conjugate base. Same goes to this one. So HBr and then the remaining is Br minus. So HBr is donating proton while NH3 is accepting the proton. So this is the base and then the pair is conjugate acid. Next example, write the conjugate base formula from the following acid. Again, we need to remember definition of acid from Bronsted-Lowry. So acid is anything that can donate H plus. So it can donate H plus, so the product will be SH minus. So HCN can donate H plus, so the conjugate base is CN minus. So this one can donate H plus. So we donate H plus here. Okay. So the remaining, the conjugate base is this one. Write the conjugate acid for the formula for each of the following base. So base anything that accept H plus. So this one accepting H plus, so becoming this one. This one is the conjugate acid. This one accepting H plus, so this is the conjugate acid. So OH minus accept H plus, so the conjugate acid will be water.